Okay, so in this video I'm going to have a look at solving linear inequalities. Now just to start off, I'm just going to have a look at what an inequality is, and then I'm going to have a look at what natural numbers, integers, real numbers are, and then we look at solving some actual inequalities themselves and plotting them on number lines. So first of all, an inequality is just simply something that isn't equal to something else. So it's either greater than or less than. So for example, if we say 3 and 5, we have two numbers 3 and 5. Well, 3 is going to be less than 5. It's not equal to it, it's less than 5. And we use this symbol here, a less than. If we switch them around, we would say 5 is greater than 3. So we use this symbol here. The larger side of this symbol, if you like, is on the side of the larger number. The smaller side of this symbol here is on the side of the smaller number. So that's less than. 3 is less than 5. 5 is greater than 3. In fact, when I said they weren't equal to, we can use a symbol like this: greater than or equal to, and less than or equal to. So for example, if we have a number or variable x, we can say x is greater than 5, or it can be equal to 5 either. In this case, we would say x is less than 5, or it can be equal to 5 either. So these are the type of inequality symbols that we can use in this section. So let's have a look at some symbols that we're going to be using to do these questions. We're going to first of all look at the symbol n, which stands for natural numbers. These are natural numbers, and natural numbers are just the positive whole numbers, so 1, 2, 3, and so on. They're all your natural numbers. Another symbol we're going to use is z, and that they're just integers. Integers are numbers that can be negative, so -2, -1, 0, 1, 2, and so on. So they can be negative, positive, and they include 0 as well. And then real numbers are just any numbers that can be plotted on a number line. So they include the numbers in between these whole numbers, so the fractions and decimals in between these whole numbers. So we're going to solve inequalities, and what we're going to do is plot the solutions on a number line. So let's have a look at some examples that we can do. So the first one I'm going to do here is 2 times x minus 1, and we're going to say that that's less than 4x. We want to solve this inequality here. We're going to say also, by the way, that x is an integer. So when we solve it, we're going to say that x is an integer. It's going to be one of these numbers here. So how do we do that? Well, let's have a look. Well, you really solve it the same way as you would normally solve equalities or equations. So as if there was an equal sign here. There will be one slight difference, and we'll have a look at that later on. So let's have a look here. We just multiply out this bracket here first. So we have 2 times x, which is 2x. 2 times minus 1 is minus 2. That's less than 4x. Now, as with all of these type of things, we try to get the x's on one side and the numbers on the other side. So I'm going to take, in fact what I'll do is I'll take this 2x here, and I'm going to move it over to this side of the inequality. So I mean, from previous videos that I've done, you might remember that we would stick in a minus 2 here, minus 2x rather, on this side. We'll stick that in there, so plus 2x minus 2x will just give us 0 here. So we would end up with minus 2 on this side. Now, to keep it the same, what we really need to do is we would put in our 4x on this side, and then what we need to do is also put in a minus 2x on this side as well. So you'd put in a minus 2x on this side, 1 on this side, 1 on this side. So what we end up with is minus 2x here. Okay, so we end up with minus 2 is less than 4x minus 2x is just simply 2x. Again, what we do here is we just divide across by 2, so we end up with x greater than minus 1. Divide minus 2 by plus 2. Okay, so we have our solution here. X is going to be all the numbers greater than, the large side of this symbol here is on the side of the x here, if you like, so it's x is greater than minus 1. But we're also told here that x must be an integer, x must be an element of z. So we've got to plot this now on a number line. So let's plot our number line here. So we've got numbers down along here. So we'll start with, say, minus 2, minus 1, 0, 1, 2, 3, 4, and that goes on into infinity there. Now we want to plot all the solution of this inequality here. So what do we do? Well, we know that x has to be greater than minus 1. Well, there's minus 1 there. X has to be an integer. Minus 1 is an integer. That's fine, but it has to be greater. What's the next integer bigger than minus 1? Well, the next integer bigger than minus 1 is 0. So I'm going to put a dot there. Also, I'm going to put a dot here on this integer, this integer, this integer, and this integer here. So all of these integers are greater than minus 1. So this is the solution plotted. It includes all the numbers up along here as well, all the whole numbers. So that's our first question finished. Okay, so let's have a look at another one. Okay, question 2. Let's take 5, let's say 5 times 2x minus 1 is greater than 2, well, no, let's say we put that outside the bracket, so we'll say 2 times x minus 1 and plus 5. This time we'll say that x is an element of n. So x at this time is a natural number. So let's have a look at solving that. So again, we do the usual. Multiply 5 by 2x here. We get 10x minus 5 greater than 2 times x, 2x minus 2 plus 5. Okay, so let's see, do I have that right? 2 5's 10, 5, 2x minus 2 plus 5. Okay, so now what I'm going to do is I'll just add these two first of all. So I've got 10x minus 5 greater than 2x minus 2 plus 5 is plus 3. Okay, so now what I have is a 2x here. I'm going to bring that over here. So it's going to be 10x minus 2x. I'm going to bring this minus 5 over to this side. So that's going to be 3 plus 5. Okay, so let's just do out each side. And 10x minus 2x is 8x, 5 plus 3, 8. And then when we divide across here, we get x is greater than 1. Okay, so when you just need to plot this on a number line now. So we draw our number line as usual. Now this time our x's are going to be elements of n. They're going to be natural numbers. And remember that natural numbers start at 1. So we got 1, 2, 3, 4, 5, 6, 7. If you're doing this in an exam or whatever, use a ruler and use equal divisions here. I'm doing this freehand, so it's not absolutely accurate, but you get the idea anyway. X is going to be greater than 1, so let's just plot our points here. So x is bigger than 1, so there's 1 there, so we don't include 1. X is a natural number. These are all our natural numbers, so I'm going to put a point here, 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 and here. And that's it. That's our second example. Okay, let's try another one. So this is question 3. Now I'm going to do 3 times x minus 6. 3 times x minus 6 is less than or equal to 4 times x minus 1. 4 times x minus 1 minus 15. And this time I'm going to say x is an element of or. X is a real number this time. So I got 3 times x minus 6 is less than 4 times x minus 1 minus 15. So let's solve this. So again, multiply out the brackets here. You just do 3 times x, 3x minus 3 6 is 18, less than or equal to 4x minus 4 minus 15. So let's just do that. 3x minus 18, less than or equal to 4x minus 19. Minus 4 minus 15 is minus 19. Okay, so now I'm going to bring this 3x over to this side. Usually you'd bring the smaller value of x, the smaller coefficient of x, over to the bigger value, or the bigger coefficient of x, to keep your x's positive, if you like. It doesn't really matter, you'll get the same answer whichever you do, but normally I would take the smaller coefficient. Bring it over here to become minus 3x. I'm going to take this minus 19 and bring it over to this side. So I end up with minus 18. This is a minus 19. When it comes over, it becomes plus 19. This is 4x. That's a plus 3x. When it comes over, it becomes minus 3x. Okay, so let's see what we got here. We have minus 18 plus 19 is 1. 4x minus 3x is 1x. So I got that right. Minus 18 plus 19, 1, and 4x minus 3x is 1x. Okay, so we have our solution here. We've got x is an element of R. X is a real number here. So let's just plot that. Now we have our number line, and our real numbers go off in both directions here. So let's see, x is going to be greater than or equal to greater than or equal to plus 1. So let's just put in some numbers here. Let's say minus 2, minus 1, 0, 1, 2, 3, 4, 5. Okay, now x is going to be bigger than or equal to 1. Here's 1 here. Now we need to include all real numbers on the number line bigger than or equal to 1. So we've got to include 1. So what I'm going to do here is just put a dot there on 1, because we've got to include 1. It's equal to 1 as well. Now it also includes all of these values here between 1 and 2, between 2 and 3, between 3 and 4, and 4 and 5. It also includes 2, 3, 4, and 5, and so on. So really what we've got to do is just do this kind of line up along here like this to indicate that we're including, that our solution includes all of these numbers on the number line greater than or equal to 1. Now there are just some points I want to make here. When we talk about x being an element, x is an element of OR. Okay, now let's say, for example, this is the solution to the question I've just done, but let's say for argument's sake that x was greater than 1. Okay, say this was the solution to another question we got, and we know that x is an element of OR. X is a real number. So this is a solution to another question that we did. So how do we plot that? Well, let's see. What we're going to do first of all is just draw our number line again, and our real numbers go off in both directions. We'll start here with, let's say, minus 2 again, minus 1, 0, 1, 2, 3, 4. Now we want x to be bigger than 1. Here's 1 here. So we want x to be bigger than 1, but we want x to be real numbers. So that means we've got to include all of these numbers to the right hand side of 1, but not include 1 itself. So the way we represent that is we put a circle around the 1, don't fill it in, don't color it in here, and then we just draw our little river for river, if you like, our line up along here like this. So this represents our solution, x being greater than 1. X is bigger than 1, but it doesn't include 1. It's not equal to 1, so we don't actually fill this little circle in here. So that's the first point I want to make. And the second point when dealing with inequalities is this. Okay, I'll just put a little line there. Now what we want to do is, let's say we end up at we solve our equation, or we do the procedure where we start to solve our equation. We end up with something like this. Minus 3 is greater than let's say minus 3x is greater than, let's say, 12. Okay, so we end up with something like this. So what we've got to do now to get rid of this minus 3 here on this side, we've got to divide both sides by a minus 3. So if we divide this side here by minus 3, we've got to divide this side here by minus 3. This will divide in and we'll get 1 here. So what we'll end up with here is an x on this side. Minus 3 divided by minus 3 will give me 1. So there's a 1 here, 1x. On the right hand side we end up with 12 divided by minus 3, I don't put that in, sorry, that's a mistake there. Okay, so what I do here is I divide 12 by minus 3 and I get minus 4. Now the thing about it is we divided both sides by a negative number, so what in fact we have to do is switch around this symbol here from pointing this way to pointing this way. X is less than minus 4. So the general rule is if you multiply or divide by a negative number, you must switch this symbol around. You must switch it from this direction to this direction or vice versa, depending on what your symbol is. So for example, if you take a practical example, let me see, let's say if you take minus 4, minus 4 is going to be less than, let's say, 8. Okay, so on the number line, minus 4 is further to the left down the number line than 8. Now let's divide both sides by a negative number. So let's say we divide the left hand side by let's say minus 1. We divide that side by minus 1, so we divide this side by minus 1 as well. So we're dividing both sides by minus 1. What do we end up with? Well, if you look at the left hand side, minus divided by minus is plus, 4 divided by 1 is 4. Now plus divided by minus on the right hand side is minus, 8 divided by 1 is 8. Now look what we've got. We've got a 4 and a minus 8. 4 is in fact bigger than minus 8. So 4 is greater than minus 8. So you can see here just a simple practical example without any x's. If we divide by a minus number, negative number, we find that the symbol will need to be switched around. And it's the same if you multiply. I mean, if you take, again, if we take our 4 and let's say our minus 4 and 8 again, minus 4 is less than 8. It's further to the left on the number line. Let's say we multiply the left hand side. Let's say we multiply the left and the right hand side, let's say this time by, let's say minus 2. I'm going to multiply the right hand side by minus 2 as well. Multiply by minus 2. I'll just actually put that in front there. So we're going to I'm going to multiply this by minus 2 as well. So what happens? Well, minus times minus is plus, so we end up with a plus, and 2 times 4 is 8. Minus times plus is minus, 2 times 8 is 16. Now this time we look at our two numbers, we've got a plus 8 and a minus 16, so plus 8 is in fact bigger than minus 16, so we ended up having to switch this symbol around again. So basically, just to summarize, if you divide or multiply by a negative number, you must switch this symbol around. Okay, that's it for this video.